Hi everybody, we're working on a relational database in SQLite and Python. We will do this also on projects in Java and in C++. The nice thing is the SQL is exactly the same. How it's implemented in each programming language is a bit different, but the SQL is the same. Before you start this, you want to make sure that your tables are related properly. So one of the things that we want to do is make sure your design is good before you start putting this code in. Much of this code you've already done with the previous assignment. Before we go through the code, let me go through there we go. When you are, originally this database had everything over here, including the artist. Anytime we have something in a table that can have the same information in it more than once, we want to break that out typically as a separate table. So this table contains all the information about the artist. That gets tied to this table with the foreign key artist ID. So we can have a one-to-many relationship. The song ID is the unique identifier for the song database. Now if you were to go further, and this is called first, second, and third normal forms, you might take genre out into its own database and to its own table, because probably there's going to be duplicate genres in this, so then you can make another connection. For our purposes, we just want this. Taking one piece of duplicated information from here, putting it into its own table, connecting it up with a primary key here to a foreign key here. That does mean, however, before we can create the song record, that does mean that we have to have the artist record created first. And you'll see the same thing when we create our database. Notice that in the code, we are creating the artist database first because it has the primary key that becomes the foreign key in this table. You can't create a table with a foreign key to a table that does not exist. You can't create a record that contains a foreign key to an artist that does not exist. So remember, you always do the foreign key tables first, and then the primary key. You do the table with the primary key first, then you create this, you put in the artist first. Once the artist is in, then you can connect as many songs as you wish, but you can't put a song in without having the artist record already in there. So we've done this before. Create the table if it doesn't exist. Our primary keys are automatic, integer primary key. Our constraint is called foreign key artist. So we're creating a little database artifact, might be the term. So it's saying that in this, the foreign key ARTID references table artist art ID. So it has to reference this, which means this has to exist before we can create this record and get the foreign key. On delete cascade is something new. It doesn't matter if you only have a single table. If we can delete an artist, we would have what are called orphaned records in the song. We'd have a bunch of songs in our database that don't have an artist connected with them. So typically you don't want to have orphaned records. If you delete an artist, you want to delete everything that's connected to that artist. So that'll cascade from the artist table. Like if I delete John Bon Jovi, any songs that were connected to John Bon Jovi over here get deleted. Do you have to do it that way? It's a good idea, otherwise you end up with what are called orphaned records. And then we have the little app, right? This gives us the menu system, which we've done that before. We create our tables of our two guys. We bring up the menu. Nothing's happening yet because all we've done is create the table. Now, if you want to make sure your table is created, open up the database with your DB Manager that we downloaded earlier. Then you'll see if it's there or not, or if the tables are created. That should do it. We'll see you next week.